Dear students, you have asked me some questions in my personal WhatsApp. So let me give you the answers. Your first question is, sir, what is called a machine? Can you give in just in one line? Now, a machine in which energy transfers from input to output through a proper magnetic media. That means, say, if I call it DC machine means it will be act as a generator, act as a motor. So in case of generator, you are rotating the prime mover and you are getting the electricity in the output. In that case, you are cutting the flux. When the armature is rotating, it cuts the flux. That means flux cut is there. So magnetic media is there. Say in case of transformer, there is a primary winding, there is a secondary winding. So from primary to secondary, when the supply is given in the primary, this is flux generates in the core, and then that flux links with the secondary winding as well as with the primary winding. That flux is alternating in nature. Due to the alternating nature, there is a flux cut and voltage will develop in the secondary side as well as in the primary side. So there is no rotating device, but flux cut is there. So whenever you will give this answer, when the recruiter will ask you, you must say that when the energy transfers from input to output, there must be a proper magnetic media should be present. In that case, we call that device as a machine. That's why generator is a machine, induction motor is a machine, as well as transformer is also a machine. Another student asked me that, sir, can we apply DC on transformer? I have already mentioned this thing in our class. So again I am giving you this answer. Now, you cannot apply DC on a transformer. You have to apply alternating signal, that is called AC. Now, if you apply DC, that means direct voltage will be applied. So direct current will be applied to the primary winding. So that will initiate direct flux. That means a value of constant flux. So initially, when there is no power in the primary, flux is 0. And when you are giving a direct current DC supply, in that case a high value of voltage will be there. So a particular constant current will be there. Then it will implement, due to the number of turns and the current, that is magnetic force, that will create a constant value of flux. So at that moment a peak voltage will generate. Why? Because as per the Faraday's law of electromagnetic induction and Lenz's law, it is minus n d phi dt. So initially phi max minus 0 by time. So maximum voltage initially generate. After that, in the second instant, flux is again constant. So phi 2 minus phi 1 will be 0, and there will be no voltage will develop in the secondary side as well as in the primary side. And see, if you apply direct current or DC supply to the DC supply to the transformer, in that case, that is I equals to V by R. So obviously there will be no resistance, and direct high current will flow through the winding and it can burn the transformer. So don't do that. Always apply AC supply to a transformer so that flux cut will be there. That means the flux link will be there, as it is alternating in nature, and voltage will develop and power will transfer from primary side to secondary side. In your next question, that what kind of winding or what is the winding configuration that will placed in practical transformers for low voltage and high voltage windings? So let me give you the answer. See, whenever you are using a simple kit that you are requiring a voltage of 12 volt or 24 volt, that means initially we have the sockets plugs that giving 230 volt supply. That 230 volt has to be converted in 12 volt or 24 volt. Now in that particular devices, a little small rating transformers is required, 220 by 12 volt or 224 volt transformers. Small transformers are there. But whenever it is comes regarding the commercial use for three phase, basically, that it has to be implemented in the streets, it has to be implemented in the commercial areas, factories, and in front of our college, SIM, there is a big three-phase transformer is there, distribution transformer is there. So whenever you are going to design the low voltage winding, or you are going to put the low voltage winding as a high voltage winding, you should place the low voltage winding next to the core. You should place the low voltage winding next to the core, because we are dealing with the low voltage initially. Then you have to put a proper insulation, and then you turn the high voltage winding next to the low voltage winding, because it is very difficult. If it is difficult to rectify the fault in high voltage windings, that's why high voltage winding is placed next to the core, next to the low voltage winding. Another student asked me that what are the basic requirement to draw equivalent circuit of a transformer. I have already given one study note in Google Classroom for your helping side, so that in this pandemic situation you can study it. I have already mentioned there, and I am telling you that whenever you are going to implement the equivalent circuit, there are two phenomena. One is the parameter referred to the secondary side, another is parameter referred to the primary side. You can take any one. Whenever you are taking the parameter referred to the secondary side, that means the secondary side you have to make as a constant parameters, and then you have to change the primary side, so that you can make a equivalent between the primary as well as in the secondary. Only then you can draw the transformer equivalent circuit. And if you take another consumption that refer to the primary, that means refer to the primary voltage and current will become as a constant, and you have to change the secondary side that should be equivalent to the primary by considering the turns ratio, that we know that V2 by V1 equals to N2 by N1 equals to E2 by E1 equals to I1 by I2 equals to K, that is turns ratio. So I think there will be no problem at all. So give me more questions so we can come with the next video. Thank you all. Have a good day.